Hey all, Grello here. The ISC video dropped today as expected, and it's talking about meshing and performance and some other interesting things. I'm excited to watch this, so let's get started.
So it's been a while since we had you in here. What's happened since then? Hi, Steve.
Well, we all went back home and we didn't do anything for about a year and a half, and then suddenly
Nice.
we made server meshing happen. No.
We've been busy. Busy taking all of the feedback and all of the data that we gathered during the last series of tech preview tests.
We've really been developing the technology and making sure it covers all the use cases that the system requires.
And rolling that forward
Glad to hear
into new and exciting stuff.
What new and exciting stuff?
Fellas. Meshing forward.
Ok, jump point detected! Jump point detected! Incroyable! C'est donc. Oh!
Probably gonna say those exact same
Probably
words
noticed.
as
We
I
are
go through this
pushing
the first
player
time.
counts higher and higher as the weeks go by.
Why did we do this with real players? Why don't you guys just script something or use bots? It never matches the actual real-time environment that players can actually represent. Putting real players in the build is the only way to really see the true depth of the troubles that we're in.
We talked about that in the video that I put out earlier this week when we were talking about profiling. And I said, you know, all of us playing the game are helping them dial these numbers in. Plug, if you haven't seen that video, go back and watch it. It came out on Sunday. But in there, I talked about that. Like, real players are going to get better results than any automated test. I see that on Spectrum and stuff all the time. People are like, why don't you just develop an automated system to do this? Why are you relying on... Well, he's exactly right. It's never going to match.
We'll always start out with kind of a safe test at 100 players.
But we verify here that we haven't introduced new crashes that would detriment the experience, and that the performance is on par with what we would expect for a single server with 100 players. We let that run and soak for like 30 to an hour, 30 minutes to an hour. And then once we've confirmed that that's actually functional, then we go to higher numbers.
Initially, when we were
Makes sense.
pushing up to 500 players, that was putting a lot of burden on a number of systems. It's one of the reasons why we needed to replace our message queue.
Where now we needed more parallelism into how we shuffled messages across the hybrid, because the amount of data that it has to shuffle is a lot higher than we expected.
From what I understand, same mesh, so 250, 4 servers. Right now we're at 231 players. Making our jump to Pyro system.
So we decided to take a couple of months out and completely rewrite it. We came back then with what you've heard us referring to as the replication message queue, or RMQ. So RMQ is a product of the UK networking team, so that's Clive Johnson, Dave Kaplan, Jordan Wood, Nathan Matthias, Santi Ortiz. Those guys, I mean, they really put their heads down, and I think they really delivered on something that is going to scale to the future.
Cool that they're introducing all these people. Not all companies do this. Like, you don't get this kind of visibility in just any company. So this is really cool. Probably a nice perk of working there. And when he says a couple of months for RMQ, like, that is a very sane amount of time to refactor a system like that. Probably pretty quick, actually. So that makes sense.
The intention of RMQ was to provide us with a more stable foundation. And going into the first test, because it being new code and it being written like specially for large volumes of messages, we expected it to perform better than NMQ. It didn't.
Oh, no.
RMQ is performing actually pretty good. The actual element that we identified back at the beginning of the year when we did our first server meshing test were actually solved, and we're now running at very fast speeds. But it revealed another layer of the onion.
A lot of ships over here, so yeah, probably not
It
working.
always
which is too bad.
does.
And I have no idea what's going on. Oh, the FPS. Come on, come back to me. Load, load.
We were disappointed that we were still seeing interaction delay. We were still seeing high latency. On the back end, we were seeing high levels of packet loss.
You are clear to launch.
crash.
Oh no, it's gonna lock me in. I might have to grab a smaller ship or something. Why am I locked in here? So this hangar might be busted. I just saw somebody else take off, so not all hangars are busted. That's not good.
Interaction delay is caused by messages taking a long time to go through the hybrid. So when you press F to open a door or exit a ship, a message is sent from your client to the hybrid, then processes the message, and then sends it to a game server and back to your client. So this loop, when it's too slow and takes time, will manifest itself as an interaction delay.
I see this all the time. Oh my gosh. I don't know about you, but like if our org events go south, it's usually because of interaction delay. It's so frustrating when it happens.
Now, what causes interaction delay from the hybrid's perspective is when we basically have a traffic jam on one thread. So the application is using multiple CPUs, but at some point in our code, the way we're processing it, we will be all jammed on one. That will.
I don't know if you watched the video that came out on Sunday. I was talking about the servers that'll power Star Citizen 1.0 and how you figure out like the size of the server you're going to run on, and the thing I mentioned in there was profiling and why that's important. But before I even talked about that, I talked about how difficult it can be to write software that scales to many cores. And I did my best to like explain in layman's terms like what he's describing right now, like where you have a process that's trying to take advantage of multiple cores, but you get blocked up because one core is waiting on other cores. And yeah, that's cool that it's so immediately relevant.
Create a traffic jam which will cause the messages to take a long time to do that loop, and that immediately creates interaction delay.
When analyzing issues with interaction delay, we saw that everything that was going wrong was kind of focused in on where all of the code that runs NMQ was. So when we went to try and optimize that, we discovered that we're kind of in this dead end. We can't really figure out how to, with the structure of NMQ, improve it. So with RMQ, we kind of addressed those problems kind of at their root and really thought about how we can not end up in this dead end again.
That is the jump point. So we are going to, oh, well, that is not the jump point. That is where we're going. Within that amazing visual, there is a delightful jump point for us to go through, hopefully. I'm not entirely sure if it's working. I know people were telling me, because it's in Evocati, which is a very early build of 4.0, sometimes it's not working, but we'll find out together.
What we expected from that is that we would be able to achieve a much higher throughput, which it does. It can achieve that. But by optimizing that, we see what was behind NMQ that was also causing issues, that wasn't getting the opportunity to really like stretch its legs to the point where it was able to become an issue.
NMQ was at a dead end, right? There wasn't so much we could do there, just to the nature of how that had been written. The game we were building at the time when that was written, radically different.
It couldn't grow, it couldn't evolve.
Exactly. It was limited in its nature.
Our game is massively complicated. We produce so much data from everything, not just players, NPCs, from ships, from doors, from to elevators, to just everything kind of going on that the NMQ at least, and then the RMQ just like no.
So RMQ's focus was, yes, to immediately try and solve some of the issues we had seen, but also to provide us some room to grow. And right away,
this is very common in software engineering. Like they didn't do anything wrong here. Like refactoring systems as you scale up and as you add more sophistication and complexity and user counts and all that stuff like that is par for the course with software engineering. Like you don't want to come out the gate trying to build something that will scale to the moon whenever you don't know all the details that will affect those scaling properties. Like you just can't, like you would be wasting an insane amount of time, because I guarantee you that you're going to wind up in a state where you have to refactor it anyway. So that's why they call it premature optimization. It's something you want to avoid.
way, we noticed a distinct lack of parallelization when we update dirty messages.
So a dirty variable is a piece of information or a variable attached to an object that hasn't been communicated to all other members of the mesh.
The sync dirty stuff is just absolutely, it's taking up most of the frame. So where we were originally seeing, let's say like we have this amount of space, right? We were seeing like NMQ take up this much, and then like the rest of the network update taking this much. But now we're seeing sync dirty take this much, and the rest of the network updates take this much, and then RMQ just this tiny little sliver now. So we've addressed.
Sounds like they've optimized the heck out of the message queue service. When he's talking about like this much space and this much space and this much space, I assume he's talking about network bandwidth or bandwidth within the process itself, like within the hybrid process, which goes back to the profiling stuff I was talking about, like, you know, depending on how many CPUs your process can take advantage of, like you're going to have a certain number of operations per second you can be pushing. And so anyway, I think that's what he's talking about. Like what slice of the pie are these different operations taking? Like if you're spending a ton of CPU cycles on NMQ, and that's denying CPU cycles to whatever, some other process that might be doing math calculations, like that's a problem. Okay, you got to optimize NMQ. Okay, we bring out RMQ. That reduces the CPU cycle count. Now we have more CPU cycles to spend elsewhere. And then what inevitably happens, which is what they're describing here, is like, okay, you've optimized one thing. That gives more space for the other processes or the other things that process is doing. It gives them more space, so now they start to balloon out to fill that available, right? Because as you're throwing more stuff, like your operations per second is going to keep going up. So then you see, like once you free that space up, you see how the other things that were denied space before, how they're going to scale. And it sounds like, I don't know what the thing is yet, but it sounds like something else is now ballooning faster than it should, and it's going to start denying things space. Let's keep watching.
Addressed RMQ, but oh wow, that underneath all of this, there was this other problem that never really got the chance to generate that load.
Yeah.
Oh, it's just closed. Huh. Oh no.
Oh.
Okay, lining up. Oh my god. Entry requirements met. Oh my word, this is happening. Tuning complete. Oh, the music is actually giving me shivers down my spine.
So we fix this by parallelizing the work or optimizing the work that's happening in that thread so that it goes faster. And so there's multiple approaches to this, but the number one thing that we've been doing in the first series of tests have really been optimizing and parallelizing the work for synchronizing dirty variables.
Parallelizing
So that you can take advantage of more cores.
this allows us to add more lanes. It's just like going from a single lane road onto a highway. We can just handle much more at the same time.
So the server needs to send out any change that happens to the game. You move, you shoot, and send it to every other client that can also see that entity. What happens is that then needs to go through every single client and go, oh, can you see this? Can you see this? Can you see this? Can you see this? And then synchronize dirty state. That then is what produces the message that updates you. What's a really, really easy optimization to make there, especially at higher player counts, is we can just go, oh, every single client we can do at the same time. They're not modifying any data, they're just reading it, because that's what sending it out is. You're just reading the data. And reading the data just reading the data, not modifying it, means that we can run all of that information at the same time. So with not too much work, we can get a really, really big optimization.
To me, it sounds like what he's describing there is like an optimization in how messages are sent and received, such that it sounds like the way things were working before was like you had a thing that determined what change needed propagated to other actors in the system. Like, right, so you have player one that fires a weapon, and you want all the other players in the vicinity to see that weapon get fired, so you have to propagate that state change. It sounds to me that the way that was happening before was the thing that is responsible, like the hybrid service is determining what other actors need that information, and it's sending it to that one to actor 2 to actor 3 to actor 4 to actor 5. And it sounds like the optimization they're making is changing it to more of a broadcast system, so that instead of individually sending it to one, you send the message out and you say, I'm broadcasting this to everybody, so that everybody gets it at one time. It's more of a instead of like a targeted like unicast, you're doing a broadcast, so it's more like all the actors are saying, hey, I'm interested in all these things, and then they all get it at once. I'm not explaining that super well right now, but maybe I'll draw a picture at the end.
Oh, okay. Opening jump point. Guys, what the heck, man? This is next level. Entering jump tunnel.
After that first wave of parallelization, we've seen some immediate benefits.
It's feeling really good. Server's feeling good. Knock on wood, no server errors so far, no crashes, stuff like that. So I appreciate that greatly.
We started to see reductions in those key metrics for interaction delay and game responsiveness and packet loss.
That was quite a dramatic exit, I have to say. I got very lucky I didn't just get slammed into one of these asteroids.
Can you hear me? Jump if you can hear me. I'll jump again if you can hear me. Oh, nice, you can hear me, let's go.
Things were showing signs of improvement. So you'll see that we pushed the player count up again. This was our first test going past 1,000 players. And pretty rapidly we ran into the next bottleneck, which was the binds. And a bind, in very simple terms, is effectively the connection between your client and your view of the game world to the server's view of the game world. So if I see a coffee cup on the table in front of me, it's because my client, running on my computer, has bound over the network to the server's view and knowledge of the existence of that entity.
All right.
Processing that. Sounds like what they're talking about is like slices. They're calling it binds, but like server is going to know everything that's going on. It's like on Hurston, let's just say this is taking place on Hurston. The server's going to know everything that's going on Hurston, where all the entities are, etc. You're going to have players all over Hurston, and each one of them is only going to see like a subset of what's going on Hurston. Right? So that like if you have a player in the spaceport looking at the ASOP terminals, like that player doesn't need to know what's going on in a bunker somewhere else on Hurston. It sounds to me like that's what they're calling a bind. It's like that player's slice of reality that they need to be aware of. Because you don't want to be like transmitting everything that's happening all over Hurston. You don't want to be transmitting all of that stuff to that player and like overwhelming that player's connection and making their client do a bunch of work it doesn't need to do. Like you only want to be sending them to relevant stuff to their proximity. So sounds like that's what they're calling a bind.
So here we go with more FPS drops. Huzzah.
A window is another term that I've used to describe that, like a player's window into the world. Kind of call it a window because like as you're looking through this thing, like anything that is not exposed by the window you're blind to, you don't care about. So
it's primarily the medical area is terrible. Ooh, what is this? Open. Ooh, fuses. Down with your colony.
In our game, we have a lot of entities. Last time I checked, Stanton was at well over 1 million in an average kind of game session, and numbers just get bigger and bigger as time goes on.
Ivan said there were 1 million entities. That's like starter numbers, right?
So, so that was just with Stanton. So Stanton, initially when we seed Stanton, so seeding is like just us putting all the initial state there. That is about 720,000 entities.
I am at area 18. So now we're gonna have another experience. Oh my god.
AI definitely feels a lot more variety. That's good. Looking good. Relax, pal. Just walk right through me.
After a little bit of soak time, so say a week, we see that very, very quickly grow to around 3 million entities per shard. So yeah, things grow pretty quickly, and like from there, we see things kind of continue to grow. This is kind of why we need like this big focus on like cleaning up entities and stuff like that. It doesn't just help the game; it also helps the network with the replication and the interaction delay.
So
Yeah, definitely. I heard a couple things there. I heard him say seeding. That's a term like what's the state of the system whenever it first comes online? You reboot the server, you have no existing state to load. What's the state? It sounds like about 720,000 entities is what they have. Like if you just do a fresh boot of the universe. I think he said, I don't know if he said Stanton. Go back and look, but and then he says as time goes on, like a week goes by, you're up to 3 million. So that's kind of like the rate at which players are creating entities. There's a bunch of ways a player can do that. They can summon a ship from their hangar and their ASOP terminal, right? That'll add a ship to the universe. That's an entity. They can pull a weapon out of their backpack or a med pen. That's an entity. Like, so those are all ways. And if you leave those things behind, like that's just a permanent +1 entity to the system. So when he talks about cleanup, like that makes a lot of sense. A lot of players have like talked about that need to clean up as if it's almost like a failing of persistent entity streaming and stuff like that. They're saying like, why even bother to create it? You're just going to clean it up anyway. Like no system can tolerate this. But I disagree. I think that just because you have the need to do cleanup doesn't mean that there's not benefits to the ability to persist things. I think they're just going to reach a point where they decide where we want to clean up and where we don't. But like by having these systems in place, like they have that like the power to make those decisions. Like spaceports, yeah, clean them all up. You know, surface of Hurston, like I don't know, make it realistic. Like give it a degrade time or something, so that you can find things left around by other players. Anyway, when people hear this 720,000 or this 3 million number, if you did watch one of my previous videos, you might be like thinking in the back of your head, like, wait, Grollo said 500 entities in his last video. Like I expected about 500 entities per player. I was actually jumping ahead a little bit of what they're talking about right now because they're talking about the number of entities in the entire system. Whenever I was talking about 500 entities in my last video, I was talking about like the number of entities that a player is going to care about at any given time. I was already kind of thinking about the window thing or the bind thing where like a player is not going to need to know all the entities in Stanton. They're only going to need to know what entities are around them at any given time. So that's where I kind of pulled that 500 number from. And I don't even know if that's accurate, but that was just kind of my guess at the moment. So just to clear that up.
So in order to optimize the binds, what we need to do is properly assess what part of a big bind can be done in parallel with another so that they don't interact with each other. That allows us to go wide, use more lanes to go faster. The
motorway is completely clear. We just can't get the things up the on-ramp fast enough. So what we're trying to do is basically add more on-ramps. So with binds, what that means is we might have the same number of entities that we need to actually get that you want to see updated. But what we can try and do is try and do that faster. So with parallelization, with some clever optimizations, among other things, hopefully.
This makes a lot of sense. I would imagine there's a ton of optimization work to do in this area. I think, so the first gentleman there, Benoit, was talking about like large binds and I don't know what terminology he used, but he's describing the optimization of like identifying what the overlaps are between multiple large binds. So like if you have two players in the world and they're very close to each other, I think this is what he's talking about. Like figure out like where those, if you imagine that each bind is like a circle, like a little porthole into the world, and you have two players and they each have like their circles, like where those circles overlap, it sounds like is an optimization they're thinking about making, so that like maybe if half their circles are overlapped, like they could do the non-overlapping half of each circle individually, and then the overlapping part of the circle 50% in parent, like basically broadcast that to both players at the same time, so that you're only calculating those updates one time, even though there's multiple players interested in it. That sounds like the optimization he was talking about. And then the second gentleman, it sounded like he's talking about parallelizing the processing of entities. This kind of goes back to the threading thing that I was talking about earlier, like, and the difficulty of multi-process or multi-threaded programming, like where things are kind of waiting on one another. But it sounds like he's talking about, like, if you could decouple these things and know up front that, like, okay, I have these 3 entities. Let's say that 2 of them are in some way dependent upon one another. So, like, changes to one of these could impact the other entity. But I also know that this other entity over here has no relationship to these other 2 at all. Like, changes here will not affect this one, and changes to this one will not affect either of these 2. If you can optimize your system to a point where you know these things to be true, then you can put these 2 sets of entities on different threads, different cores, different processes, execute whatever calculations are required in parallel, and have them both come out the side at the same time. That would be a really good optimization to make, and I think that's what he's talking about.
Progress is looking positive. So we've been working on a lot of the more like tedious little details, which has been like kind of like figuring out how we get information into our message queue in the most optimal way possible. But that's also setting us up for being able to then be very clever about how we parallelize the bytes.
There we go. I just click on the left click on the mouse, so I open the tunnel. There we go. Here we go. We are opening it. All right. Entering jump tunnel. Here we go. So smooth. So smooth. So smooth.
That looks smooth.
Okay.
I am really excited to see this progress further. Already the jump gates feel really smooth and reliable to make use of. This is going to make a very exciting addition to the game when it comes to live, and opens up so many possibilities for the future. Everyone at CIG is doing an incredible job of bringing this to reality. Amazing work all round.
All right, so now that I kind of let the FPS kind of catch up with me here, and I'm kind of trying to let the
A plus to that. This is really hard work. Like, I know these people catch so much shade from the community that this is a Herculean task in front of them. It's exciting to see it, like, coming into focus.
all the shaders load, so that's probably hopefully a lot of what you're seeing is lag, and it's not just optimization issues, but it's starting to feel better now that I'm kind of just standing here for a moment.
We really think that unlocking that will allow us to go to at least 10x performance on the versus the current game experience on live, which is at 100 players. But this will also allow us to uncover more layers of the onion that we can optimize to go at even higher numbers on one single hybrid, which will allow us to go bigger, just like we did with RMQ from NMQ, just like we did with the 30 variables optimizations. Binds will allow us to go further, but it's not the end of the tunnel. We still have more work to do to get even more player counts on one hybrid.
This makes a ton of sense, and it's going to influence the math in my last video where, like, we were kind of predicting how many servers they would need. Like, depending on how many optimizations they make and how dedicated they are to making those, because, like, the more you optimize, like, it's kind of like an orange. Like, you start squeezing that orange, you're going to get a lot of juice out at first, but the more you squeeze it, the less and less juice is going to come out. So, like, the more optimization work they do, the harder the next optimization is going to be. And it's going to be that way until eventually they reach a point where it's not worth doing anymore. But, like, it's going to be interesting to see how far they can go with it. It's pretty exciting. And the fact that they're talking like numbers like 10x, that's actually really impressive.
All right, we're gonna see what's inside here. Oh my god, this is so crazy. Oh, too much light.
Un joueur incroyable. Bonjour monsieur.
The visuals are crazy.
We want to push further, and the message from Chris is go as big as we can, as quickly as we can. We want to do that in a way that delivers a better feeling, more responsive game. We're not just going to jump to big numbers just because we can. There's nothing stopping us going and putting a couple more zeros at the end of the player cap, but that's not going to lead to a good experience until we continue to address the bottlenecks that we know we have, and more that we'll discover as we go forward.
We have a lot that we can improve on, and a lot of that looks very, very intimidating. But excited would probably be the emotion to kind of use for it, because we've spent so long trying to figure out how we can do server meshing that we've not really had a chance to like kind of slow down and look. And now we're kind of in that phase where we can kind of look at where like things that have existed for the past 10 years can be improved. And being able to then like tear out huge systems and replace them like with NMQ and RMQ, and like really try and like make the best thing that we possibly can is really exciting.
That that resonates with me so strongly. Like I totally can feel the excitement, because and the fact that this is daunting. Like I've been in that situation I don't know how many times, like where you're looking at a system that you have and you're looking at a state you want to get that system to, and the number of things that you're going to have to refactor, change, update, get buy-in for, like it just seems so daunting at the start. And the older the system is, like the more daunting it becomes. Like systems just kind of have a way of like cementing themselves over time. But the really challenging part is getting the organization. When I say organization, I'm not talking about a Star Citizen organization. I'm talking about like a company, like a corporate organization, a corporate entity in the real world. Getting them to invest in these really large endeavors is the most challenging part. As an engineering team, it's both daunting and exciting to think about like big evolutions or accomplishments that are like yet to be won. But then trying to get like buy-in to a vision like that is really hard. Often what you're forced to do is like break this down into really small bite-sized chunks, and sell those to the business. Like, okay, don't even tell them about like this overarching thing. Let's take the first 3 months worth of work from this, 2-year vision we have and try to sell that. And then next quarter, we're going to try to sell the next 3 months of work. And it's sad, but that's kind of the state of it. And a lot of times what I see is like the vision getting lost along the way. And I can't tell you the number of times I've seen like companies veer off track or just kind of push the pause button or just scrap it as a result of just never really connecting that long-term value to the work being done today. And it sounds like these engineers on the screen right now, like they have that buy-in from the top. They have that grand vision from Chris Roberts. They have the support that they need to do something this big. And that's why I think you're hearing them say daunting and exciting in the same sentence. Like I can totally relate to that.
So what did we learn this week? That the progress of moving server meshing forward is only made possible with the help of testers like you. That each new win like RMQ peels back another layer of the performance onion to be addressed next, like Bond.
I wonder if Jared's going to grow his beard back. He still looks weird to me.
Which since the time these interviews were recorded have made tremendous progress and are already revealing the next layers underneath. And that this work doesn't stop with the upcoming Alpha 4.0, because as the game grows to the sights set in Star Citizen 1.0 and beyond, so too must the efforts to continuously optimize. And I want to give a special thanks to Star Citizens Adder Moth, Citizen Kate, and Will, Dominguez, Even Lease, Hybrid V, Le Regular, tried, Morphologist, Ollie43, Speedfragger, and Tarada, as well as everyone else who's been documenting this process from the other side of the table. For Inside Star Citizen, I'm Jared Huckabee. Thanks for letting us share the people and process of game development with you. And as next week is IAE, instead of ISC, there's going to be something a little bit different coming your way next Friday. We'll see you there.
Cool. I really enjoyed this. Hope you did too. Hope my commentary was added a little bit of value to it. But yeah, I was excited to watch this all week. I heard last week that they were like this was going to be the topic of this ISC, and I can't say that I get this excited for all ISCs. I mean, I love ISC. I love that CIG does ISC. I do look forward to them in general, but I don't always get this excited. I was pretty excited when I heard about this being the topic. So, and it lived up to it. Benoit had put out an interview a couple, like back whenever, like during CitizenCon, except it was in French, so I couldn't understand it. But somebody did a translation on Reddit, and I kind of read through that. I was actually planning on kind of doing a video on that, but then I heard that they were going to be doing this, so I just waited. And I think they touched on pretty much everything that was in that. I'll have to double check. It might be worth some kind of a quick follow-up or something. But we'll see. And before I let y'all go, I mentioned maybe drawing a picture to describe this. Some of those concepts that they were talking about might not be super clear with hand waving, so I'm going to draw one picture before I let you go. Okay, I just wanted to give a better visualization maybe for the two of the concepts they talked about in that video, which one was the frames and the other was what they were talking about around doing multiple messages at the same time instead of individually. So the way I would say to think about frames is if you have Karsten, player 1, player 2, player 3, player 4. Maybe you also have player 5 and player 6 over here. You got a party of people over here on this side of the planet. Each one of these is going to have like what they can see, right? And even a little bit kind of further than what they can see is probably within their frame because it's almost in their frame. But so this is kind of a simple representation of what a frame would be, where each player only cares about the entities in their frame. And so, and this goes back to what I said during the video, where like, they're in my previous video, I was talking about, maybe around 500 frame or 500 entities per player, and they're talking about like 720,000 to 3 million. They're talking about entities within the system. I'm talking about entities within the frame. I didn't call it a frame at the time. I think of it more like a window, but so yeah, you might have 500 entities here and 500 entities here, and they all kind of add up to the totals for the system. Now, that's a frame. Now, see our party of player 3, 5, and 6 over here. If we zoom into that, and we have 3, I forgot already. Player 3, player 5, player 6. Another optimization they were talking about making is something like this. Like I mentioned in the video, these players might be close enough that their frames are overlapping, but not completely. So you wind up with something like this. This section and this section are overlapping bits of the frame, right? And then you have the other 3 clear sections that are not overlapping. So it sounds to me that one of the optimizations they're looking at making is identifying these overlapping areas and just handling these 1 time each instead of 2 times each, and sending the results to both player 3 and player 5 in that case, or player 5 and player 6 in this case. And then the rest of that non-overlapping will just be handled like normal. It'll be processed and sent to the individual. It may seem like that's a lot of work for not a whole lot of optimizations, and that may be true in places where you don't have a lot of players, but this kind of optimization will have a huge impact anytime you have a lot of players within a small area. Right? Imagine instead of 3 players, you have 100 players here. And what if 80% of the entities in that area are overlapped across like 90 of those players? Well, then now this optimization would be huge if that's the kind of optimization they're talking about. And the last optimization I just wanted to maybe give a visual to was they were talking about like the dirty variables and getting those replicated to all the interested parties, and how like it sounds like or at least I don't know if this has already changed or it's in the process of changing, but like, so you have player 1 here, and then you have player 2, player 3. This is a different thing we're talking about now. Player 2, player 3, player 4. And so some variable changes on this player, like he takes his helmet off. Right, that's a variable that has changed, and that needs propagated to these other players so that they can see that helmet taken off. And it sounds like right now what's happening is the hybrid service that is responsible for propagating these changes to the other players is identifying which players are interested. Maybe you have player 5 all the way over here, but the system determines player 5 is not interested in this change. He's not close enough, whatever the reason is. But it does identify player 2, player 3, and player 4. And so it individually sends this update to each of these players. So it's like 3 discrete actions to transmit that. And it sounds like the optimization they want to make is that instead, player 2, player 3, and player 4 are all kind of plugged in, subscribed to state changes from player 1, so that whenever that helmet comes off, it transmits that one time. All of the other players or whatever are attached in such a way that they all receive that update from that one signal. So it sounds that's called a broadcast. Could also be called a multicast, although that is not typically something that you do over the public internet. So I would assume this is like more of a broadcast type of system that they're talking about moving to, rather than a unicast. So anyway, I hope those 3 quick visualizations might have shed some light and given you some more kind of context or understanding on some of the things that were talked about in the video. I thought, I thought the video was fantastic, and I look forward to more stuff like this. Look forward to the next IC. I look forward to seeing what they're talking about, like the special thing next week. We'll see what that's all about. Anyway, hope this was enjoyable for everybody. Unhinged.gg. A lot of people have joined the Discord, and there's a lot of great discussions going on in there. I would love to have even more people join the Discord server, so just go to unhinged.gg or follow the link in the description. Jump in the Discord and start conversing. Or YouTube comments, just as good. Jump into the comments. Let me know what you think of this ISC. I certainly have like my perspective as an engineer and as an architect and about the things that were discussed, but I would love to hear your perspective. We all kind of look at life through a straw, and there's a lot of viable perspectives out there, and I would love to hear some more of them. So let's carry the conversation onward in the comments, and I will see you there. See you next time, all.